Hello friends, welcome to Blessed Excellence Center. Don't wait to subscribe to our channel. This is Chemistry Demystified with EB Christian. Today we are looking at periodic table and effective nuclear charge. Before we go to consider the effective nuclear charge proper, I just want to remind you of something about the atomic structure. This structure you're seeing here is the diagrammatic representation of atomic structure. You see the structure at the center composing of red and yellow color, that is the nucleus. The red color represents the proton, while the yellow color represents the neutron, okay? So the two, both the proton and the neutron, constitutes the nucleus. The space surrounding it is called the shell, and then embedded on the shell is the electrons, the blue dot you're seeing there, they are the electrons. So I just want to remind you also that the inner shells are called the core shell. The inner shells are called the core shell, while the outermost shell is called the valence shell. Then again, the electrons on the core shells are called core electrons, while the electrons on the outermost shell are called the valence electrons, because they determine the valency of the atom. So how to remind you of that, let's look at the effective nuclear charge. What's effective nuclear charge? Effective nuclear charge is the net charge the valence electron experienced. The net charge the valence electron experienced. Now, in this atomic structure you're seeing here, I've already reminded you of what atomic structure is. Okay, good. So this is a typical diagram for atomic structure or atomic diagram of oxygen. The center here is the nucleus. Then electrons are on the first shell and on the second shells. Okay, good. Now this nucleus you're seeing here is composed, as I've told you earlier on, of positive charge and neutral species being the nucleus. So it exhibits, neutron. The nucleus has a positive charge. So the charge of the nucleus is called nuclear charge. The charge of the nucleus is called positive charge. Then the nucleus also exhibits some influence on the valence electron. So the net charge of the valence electron, the net charge the valence electron experience, is what we call effective nuclear charge. And the formula for effective nuclear charge is proton minus core electrons. I've already told you what core electrons are. They are the electrons on the core shells, that is the inner shells. Okay, good. So for you to calculate the effective nuclear charge, just get the proton, subtract it from the core electron, and that gives you the effective nuclear charge. Okay, good. We're going to do that for this periodic table. Now, in this periodic table, the elements arranged in this vertical form are called the groups. So this is group 1, group 2, group 3, group 4, group 5, group 6, group 7, and finally group 8. Those arranged horizontally are called period. Period 1, period 2, period 3, period 4, period 5, period 6, period 7. So we're going to pick period 3 to calculate the effective nuclear charge of all the elements in period 3. In period 3, we have lithium, we have beryllium, we have boron, we have carbon, we have nitrogen, we have oxygen, we have fluorine, we have neon. Okay, so let's see how to calculate the effective nuclear charge. The first element in the period is lithium. So this is lithium. Okay, good. The atomic number of lithium is 3. So the first shell we have 2 electrons, which is 1 and 2. The second shell we have the remaining 1 electron, which is 1. You are seeing here. Okay, good. This is the atomic diagram of lithium. Remember that the formula for effective nuclear charge is proton minus core electron. Atomic number is the number of proton in the nucleus of an atom. So the number of proton and atomic number are the same. It means therefore that since the atomic number of lithium is 3, it means that the proton is also 3. So the proton of lithium is 3. So how many core electrons are there? This is the inner shell, that is the core shell. How many electrons are there? 1, 2. It means lithium has 2 core electrons. So we say minus 2. If you subtract this from this, you're going to have plus 1. Therefore, the effective nuclear charge of lithium is plus 1. Okay, good. Now let's proceed to beryllium. Beryllium has atomic number of 4. So the first shell we have 2 electrons, which is 1 and 2. Second shell we have the remaining 2, which is 1 and 2. Okay, good. Since the atomic number is 4, it means there are 4 protons. Okay, so 4 minus core electrons, how many? 1, 2. Okay, so 4 minus 2, that gives you plus 2. So the effective nuclear charge of beryllium is plus 2. Next is boron. Boron has atomic number of 5. So the first shell will have 1, 2 electrons. The second shell will have 1, 2, 3. Altogether 5. Okay, good. So since the atomic number is 5, it means there are 5 protons. So 5 minus the core electrons is 1, 2. So 5 minus 2, that gives you what? 3. Therefore, the effective nuclear charge of boron is plus 3. Use same method for carbon, you're going to have plus 4. If you apply same method with nitrogen, you're going to have plus 5. Same with oxygen, you're going to have plus 6. Same with fluorine, you're going to have plus 7. Same with neon, you're going to have plus 8. And that is virtually how to calculate the effective nuclear charge of any atom. If you observe very well, the effective nuclear charge is increasing in that order. As you go down as you go across the period from left to right, from lithium left to right this way, the effective nuclear charge is increasing. Remember, I told you guys that the effective nuclear charge works in opposite direction to atomic radius. So as the effective nuclear charge increases, the atomic radius decreases. So it means then that since the effective nuclear charge is increasing this way, the atomic radius is decreasing this way. Anyway, that's not part of our class for today. Our main class for today is how to calculate the effective nuclear charge, which I've shown you guys. So summarily, when you want to calculate the effective nuclear charge, simply pick the proton rather, subtract it from core electron, and that gives you the effective nuclear charge. I'm sure you are blessed by the video. Thanks very much for watching. If you have not yet subscribed, do wait to subscribe. Like the video, share it, drop your comment, and click on the notification button.